Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about how to query and transform and build into a single tool in XML. We will discuss different parts of querying and help that how it is compared with an SQL and help in different parts of function types, data types, procedures and features of querying and transformation in SQL or the XML data. As we know that querying means to fetch a data from a database and transformation means to help that database in form of a user-defined language. Now XML just combines these two into a single notation known as querying and transformation on language built into a single tool. Now it uses the following languages. First is the XPath. The word XPath defines every path that expresses a path from the root node to the children node that we can have inside an XML sentences. Now next is the XQuery. Now XQuery uses the XPath to have which query they will use and to which relation or element they will get from this XPath. Now the XSLT uses for the XML transformation to a single tool that it will build on querying and transformation. Now to start with an XML querying and transformation, first the modeling of data should be known. That XML uses a tree modeling structure. There will be a hierarchy, like first the upper node or the root node will be there and from it the children node will be there. Say for an example, we have university as our database, so it will be our root node for the XML query. Next, if we have their elements as a sub-element to the university, say the relations, department, the instructor, or the courses, then we will have its nodes on a tree, and after that the children node of this ones will be the attributes to each of the field. Now in this way XML follows a tree modeling of data where there is an ordered notation of it. Say for an example, if this one the statement lies, then we can say there is an exact ordering of first this is a will be there, after that bolded book will be there, and after that of fantasy will be there. So the exact sentence this is a book of fantasy will be divided into three parts following in an order. This is a book of fantasy, three constituent part. So that is followed by the XML. The tree of modeling on the ordering of the modeling is in a hierarchy basis. Now let us see that the example of an XPath. As we have defined that XPath expresses every path that from the root node to the children node that I want to access. It cannot have the other than root node access to the children node that we are mentioning. We can have skipped the path, but first the root node has to be mentioned. Now if XPath equals to this, then we can have signified that followed by a slash, that means it is the root directory university. After that we have the element instructor, and after that we have the element name. So we want to fetch all the names that belong to the instructor element of the root element university. So the result to this query will be, now let us see that enclosed within a tag name, we will have all the names of the instructor relation. That is the instructor elements on the university, and the name will be displayed here, enclosed within a name tag. But as a result of the query, we do not want this name tag to be displayed as an output. How to remodify the XPath so that we can have only the names, not the tags. Now at the hierarchy we will move first university to the instructor, then we'll fetch the name, then it will perform the function text on it. The function text takes the previous names as the input to it and just fetches only the text part. We know at the first of an XML the markup keyword. The markup keyword is the tags or the words that is not intended to be displayed to the output or the prints. So here we will take only the text, that is the value to the fields. Now we will have Kim and Karth as our result. Now if we say that the left to right hierarchy, that means if we just write /university, that means it will return a single node university. But if we have written instead of it, it could have returned all the elements of instructor, that is being a child of the university. That means the instructor is a part of the university, so it defines an inheritance or a hierarchical relationship between this instructor and university. Now if we want to select a particular zone or a characters based on some predicates, the predicates can be enclosed within a third bracket and we can have their value as a result. Now in this way we can have the university and course based on a predicate that its credits is greater than equals to 4. That means if the course has got a credit greater than 4, then all the course details like the course ID, title and its credit will be returned as our output. But if I want a particular attribute course ID based on this predicate, that my query is I want to fetch the course ID of the courses whose credit is greater than equals to 4. So now how will I configure my query? So the character @ gives access to a particular attribute value on that element course. So here the course ID will be returned on the predicate credits is greater than equals to 4. We could have used a set of attributes also by separating it with the comma. Say I want to fetch the course ID and the title on the course element where credits is greater than equals to 4. So we could have used course ID comma title as a set of attribute values to it. Now the XPath as also consisting of the numeric function like the count, max and mean, so that we can use the aggregate functions in calculating and selection of a predicate. So in the predicate we can use the aggregate functions like count, max, mean inside an XPath. Now say I want to fetch the values inside the count one. Let us look at this query. Let us look at this query very carefully. We have fetched the university's instructor. Now as the predicate, the first one is the count function. So we will count something. What we will count? We are going this dot sign. That means from the current directory, we are moving to the teaches element now, and from teaches to the course element now. So how many courses the instructor is teaching? If it is teaching more than 2 courses, that means we will count the course in the teaches relation that has got a relation or reference with an instructor element. Then if it is greater than 2, so we will have the names and all the information on the instructors. So we can use the dot sign to move from the current directory and change the directory from the root to the teaches now, not the instructor. Now we can also use the and or just like in the SQL for the predicates and not for the negation. So not equals to will be suggested by the keyword not, not followed by equals to sign. Now let us look at this query. Say I want to fetch the instructors who has got the salary more than 65,000 and also who is not belonging to the department computer science. Now we will have the salary greater than 65,000 clause along with the and, that means the next predicate will also be checked. Department name not equals to computer science. That means department is not belonging to computer science. Now even we can use the attribute name as the function to and a value. Say I want to fetch the ID of in particular instructors whose ID has got foo or the I01 value. So how will I construct it? So just like the and, it will use the or, that salary is less than 30,000 and greater than 15,000. So here we are mentioning a range by this or operator between 15,000 and 30,000 in SQL. Now let us use the ID keyword for having a particular value. Say I want to have the instructor name who belongs to some department. So how can we get that? Now, this query will result in fetching the course IDs of the course who has got the department name. That means the department-wise course ID based on a particular department. So, if the course is belonging to the physics department, all the courses will be listed. After that, chemistry. After that, maths in this way. So, this is more like SQL grouping. Now, if I change this one by this sentences. Now, the difference between this one and this one uses ID ref, where the next one uses ID refs. That means it will consist of the course and the corresponding IDs which belongs and has a reference to the instructor relation or element. Here I am dealing with more an attribute, and here I am dealing with more an element or a relation. So the ID ref and ID refs both can be contained within the ID or the particular name of the attribute that is being the referenced one to the referencing relation. Now say if we want to join two relations based on a predicate. So we can do this with the OR operator with this sign. So here the computer sciences courses and biology courses will be returned in the exact same order, union and the way they who appears in the course element. Now this not or the OR operator cannot be used inside a nested of other operators of other predicates. So we have to use simply by two queries and merge it within union operator or a single pipeline operator. Now say I do not want to know that from which instructor or for which course, which teaches, what element we are using, but the actual attribute we know. So without the full knowledge of the schema, we can use it just as a prediction that we have used in our doc file dot sign. We could have replaced it with a double slash. So the double slash suggests that the root directory is being mentioned and number of steps can be there, or number of children or nodes are there. There can be sub-elements or attributes, and finally I'm mentioning the attribute name. So it will fetch all names that forms anywhere in the university database. So if any attribute has got the name, then it will be fetched by this XPath. So it is the very short form of using dot operator that will have any descendant number of nodes inside a tree structure. Now, if I use the particular keyword doc, that is a function type and predefined one in XML, and after that we give a particular XML file name, as we know that the queried letter will be stored in a file or an XML document itself. So if we consider the XML document, then we could have mentioned inside the doc function name followed by the specified URL, so we can get all the names of that particular URL. Say for instance, if we particularly use the XPath in the XQuery, so it will fetch me all the departments that belong to the university using the file university.xml. Now the doc can be replaced by the keyword collection. But the only difference between the doc and collection is a collection of documents. So if we have got 3 or 4 database that is a relationship between them, then we could have used the collection instead of the doc function. Say we could have used a namespace of an XML inside the collection so that we can use that particular Yale University department on that particular namespace Yale. So we can use the collection instead of the file doc. Now that we know about the XPath, we can use this XPath inside the XQuery of the XML query. The XQuery was first introduced by the WWW consortium or W3C consortium, and it was first introduced on the year of 2001 by the SQL standard. Now the XML follows the FLWOR query standards, that is for, let, with, order by, return. So this standard is mentioned while having an XML query. So to have query in an XML, we have to follow first the for, then the let, then with, order by and return. We cannot go any unordering between these statements or the type standards on XML. Now let us solve some queries so that we can know each use of this one. Now we will solve the query that I want to use the course ID and get all the course IDs whose credits are greater than equals to 3. So in the XML query or the X query, we can have it just like first using the for keyword. So we can see that the for keyword is very same just like the from clause inside an SQL statement. From which relation? So here I am mentioning for which relation. For $x means for every tuple or the attribute value present in this database, that means university to course. We need an XPath for an XML query on XQuery. So the XPath we are using is university/course. That means we are using the relation or element course. Now let is for any type of assumption or if you want to store a value inside another one. So here CID we are using and we are letting the CID equals to the course ID of the course that we can fetch from a tuple X. So now the predicate we are giving using the $X for the tuple where the credits is greater than equals to 3, we are selecting the CID. That means I'm having the name as the CID. So it is creating like aliases with the let command. And finally, the select command is replaced by return here. So what we are returning, that means we are having the values displayed. So it is more like the select statement. So where is the same like SQL where we are mentioning some predicates to it. Now look at the return statement. It has got and tagged, that is CID. The tag name, that user defined tag that XML supports CID, and I am returning all the values inside a curved braces, and here I am using the CID as the alias name, so I'm returning this one. So this is the basic structure of having an XML query. Now how can we shorten the query? Just using this $X sign. Now let us write an equivalent query to this one where we will use the shortest sentences. Let us look at this one. This is also an X query where I am using for $X in university course followed by the XPath syntax of giving a predicate that is using a squared braces without using the where clause inside the X query. Also, we have removed the let clause just by not renaming it, directly using the $X at the CID. That means we will first select the tuples and then select the particular value of CID from the tuple whose value is credits greater than equals to 3. Now the return statement again can be remodified by not having the tags, just having the attribute name, because CID is an attribute name, not an sub-element to the course, if we can remember. So we can have just like the attribute return statement of this return statement. So this is combined in an XML tag within an XML path or an XPath, that we are using the CID as the attribute name to the course. So we could have used the let and where, we could have used the XPath syntax of giving predicate, and also we could have used the attribute name other than defining it another attribute for it. Now if we have joined more relations and has got many of the attributes from any of the relation, so how the return statement will look like. So here we are returning the course relation with the attribute CID and department name from the CID and department name of course as the element of title and credit from the title and credit of course. So it is just creating a view of a relation that we are creating. So now we will go for the join one, that how to join two relations in an X query and how to perform to access for the joins. Now if I want to join the course, instructor and teachers in a way that the teachers relationship provides the instructor and the course that he teaches. Now see, first I am selecting every tuples that is considered to be C from the university course, I from the university instructor, and T from the university teachers. Now there should be some conditions or predicates. We could have used the where clause for it. That means if the instructor's ID is matches with the teacher's ID, that means the particular instructor is being teaching the particular courses. Now return, we are returning the course and the instructor that is related with the teacher's relationship with the C in stack. Now we could have used the same one using an XPath. Now rewrite this query using an XPath. See here, within the teachers I am using the XPath construct that I am matching the predicates CID from C and CID from T. That means the course IDs should be matched with the teacher's course ID. So we could have used any of the constructs, and we should use that along with this the TID should match with the IID. So here for using the join, we can use the where clause as well as the XPath construct on the AND clause basis, that we are joining if the ID matches with the TID on the instructor and the course ID matches with the course ID on the course element, then we are fetching the course and instructor pair for every course that is taught by the instructor. Now we will know about nested query. Nested query in XML is just like the query in SQL, that a query will be result an output which will be in the input to the outer query. Now let us see this example. Now see, in the university tag we have two queries. The first query is having that we are selecting D or the all tuples in a department which will depart on return D star, as we know that the asterisk sign provides that 0 or more, plus provides 1 or more, and question provides 0 or 1. So either there can be 0 result or 1 result. Now by defining asterisks here, we can have that there can be 0 departments that belongs to a course or 1 or more departments. Now that we are selecting this dollar, along with we are selecting course from the course relation where the department name of the course matches with the department name of the department element, and we are returning the C here. So now we are returning C and D as a part of the single query. So the for query is having this query as an inner query. So the result of this $C will be presented here as a part of the combination to the $D. Now let us look at the next part of this query. Now here we can see that we have the instructor relation and every tuple I in this instructor, which could have 0 or more tuples in it, where the university teachers, that means the ID of some teachers, match with the teacher's ID, and we have the course ID of the $C that we have fetched previously in the part of the query can be used to get the instructor. So other than joining these two relations, instructor, teachers and course, we are using nested query to solve the same. First we are fetches the department on which the instructor is teaching, and now the course and the instructor name to it, that which courses has been taught by which instructor, and all this query is part of this university tag. Now that the X query does not support to the group by clause, we can use any FLWOR commands to go for and make the group by clause implementation of it. Now we will use the group by clause as an implementation of FLWOR. That I want to fetch for the salary of each instructor group wise by the department, and then make the total salary on the department. So I can get the total salary department wise. See, first I am selecting the department name from the department using the department tag, and now inside the total salary tag we are calculating the summation of salary department wise using the function sum. The keyword fn suggests for function. We will go for the function and types later in this video. First let us look at the sum function, where I am selecting the instructor from the instructor element where the department name matches with the department name of department relation, and now I am calculating for the summation of the salary of each of the instructor that belongs to the same department name. So the first tag will give me the department name, and the next total sal tag give me the salary of each of the department, summing it up using the aggregate function sum. Now the FLWOR, the O suggests for order by. To sort the result, we should push the order by clause, just like this one. So we are selecting from the university's instructor element the name order by the name filled on the instructor. That means every tuple's name will be fetched first, and on an ascending order we will get all the result. So we could have used the order by clause in different nesting of a query. So it is not mandatory that we can order only by a single filter attribute. Just like the SQL query, we can get an order by of the order. That first on the basis of the ordered will be there, and after the ordering another ordering will be there. So an example of nested querying, we are having this example. So in this query, first we are ordering it by the department name. So if I am selecting the course name that matches with the department name, that means the department wise courses ordered by the department name in this query and then followed by the department name on which the course will be corresponded. So here we are having selected by the course ID ordering as the inner query, and after that the ordering will be there from the department name. So we can have basis and the department name ordering, and after that we can department wise the courses followed by this course ID ordering from the department name matching predicate. Now we will see the function and how to use the function and types of function inside an XML query. So first, to declare and define the function, we use the keyword declare function followed by the function name. So first, how to declare the name? Use the keyword declare function, then the name of the function local department course, which takes as an argument the ID of the ID field on an instructor from the string, and then give the result as an element that will be a relation code star. That means based on the department wise codes, we are fetching all the courses instructor. So in the function body or definition, we are first selecting I from the instructor, where the instructor ID is matched with the ID that is given to him, that we are fetching a particular instructor and being teaching which course followed by to which department. Now how to invoke this function inside a query? Now first we are fetching the name Kim, whose instructor I put in this $I and selecting the tuple over there over the predicate that if the instructor is Kim. And now I am calling just by calling the name of the function followed by the arguments that we are taking the ID from the ID of Kim. That is $I first selected, and I am selecting the ID field of $I to get use of the ID and use the ID to get the course that it teaches in the department. Now, aside from the sorting, the resulting and this nested query and also the function and types, XML provides some other features. Now the first one is it provides that sum function where it selects some predicates. So it could be written like, so it is we are selecting some of the tuples. The keyword sum means there are one or many tuples in a following path, that means a particular element which satisfies the predicate P. Now let us see as example that how to use this satisfying a predicate and get the result. Now say I am finding the department where the instructor has got paid salary more than 50,000. So how to use this one? Now let us look at this query. It is first selecting department wise tuple, and then it is fetching the instructor wise tuple in $I where the department wise instructor and the instructor salary is also 50,000 greater than. So now I am fetching all the department relations element. So in this way it uses where every and the satisfies keyword that every $I, that means each of the instructor in that department should has got the salaries greater than 50,000. So it can be used where some $I for if some of the instructor has got paid in the 50,000 range. So these are some other features that included in the X query. That is all for the XML paths, the querying and transformation of data from the X path to the SQL one. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.